Hello, today we are going to look at the perimeter and area of rectangles. And the perimeter and area of rectangles is something we already know, we already understand. So what these questions are really going to develop is our ability to break down bigger problems into smaller pieces that we can manage more easily. But we're going to start off with a very basic reminder of the perimeter and area of a rectangle. So the perimeter of any shape is just finding all of the lengths of the sides and adding them up. That will always be what perimeter means. There will never be an exception. And we'll have lots of different tools over time for finding the lengths of different types of shapes and then adding up all those lengths of the sides to get the perimeter. Then the area of a rectangle, and a rectangle specifically, this doesn't work for shapes in general, is the length by the width. And that would also obviously be true for a square, because a square is just a rectangle that has all the sides the same. So that would be the length by the length. But for a rectangle in general, length by width. Both of these things are words that we need to know by heart and understand well, because they will not come up directly in exam questions. They will come up in a more complicated form, like what we're going to look at for these questions here. And as we move on, we'll have to get more and more creative with our understanding of perimeter and area. But looking at a very basic example, if I have a rectangle here, I know I have little right angles in all of these corners, 90-degree angles in all of my corners for my rectangle. And I have a width of 3 meters. Often our shorter side we will call the width, but it doesn't really matter, width or length. You can switch between these two. And the length would be 7 meters. So what would be the area of this shape? Well, that would be the length multiplied by the width. Would be, as I have written it, 7 by 3 would be 21. And what would be the units of that? Well, I've multiplied meters by meters, so I have meters by meters. Anything multiplied by itself would be squared, so it would be meters squared. Now, what would be the perimeter? Well, the perimeter of the shape requires us to do a little bit more thinking. If this is a rectangle, then this length here would be the same as this length here. And I have to be able to recognize that in lots of complicated shapes. So if this is a rectangle, this length must be the same as this length. So this means that that would be 7 meters. And this length here would be the same as this length here. So that would be 3 meters. And we have to be able to figure that out across shapes that are rectangles. We're going to have the same side length across from each other. So that means for the perimeter we have 3 meters plus 7 meters plus 3 meters plus 7 meters. And we add up all of our, I'll actually write it out in terms of its letters to begin with. We'll say the length plus the width plus the length plus the width. This is just writing it out in semi-mathematical. It's actually technically writing it out algebraically. But the length plus the width plus the length plus the width would give us our perimeter. So 7 plus 3 plus 7 plus 3. And when we add all of that up, 7 plus 3 is going to be 10, so we end up with 20. And this is a length, so it's going to be in meters in this question because our lengths were in meters. So that's a basic reminder of the area and perimeter of rectangles. Now let's look at a slightly more complicated situation. So here I have a length of 6 centimeters, 8 centimeters, and then I have this little corner here that is 1 centimeter here and 2 centimeters here, not drawn to scale particularly. So what I have to do when I'm given a shape like this is break it up into simpler shapes. So I have to take this complicated problem and I have to break it down into shapes that I have formulas for, into simpler situations. And there's two ways that jump out at me that I could do this. I could imagine that I have a big rectangle, the 6 by 8 rectangle. I could draw it out here. And then I could imagine that I've cut out or removed the area of this little piece here. That would be one way to approach the problem. Another way to approach the problem we might say that we had this rectangle here plus this rectangle here. And we have enough information to figure out what those lengths would be, because we know we've gone down 1 centimeter here, and the total height here would be 6. So we must have 5 centimeters left here. And our total length here, would be 8, and we've gone back 2 here, so our total length here would be 6. And we know that if it's 2 centimeters on top here, it's 2 centimeters on the bottom here. So we've filled in all of our missing lengths. So we could get the area of this rectangle here and add on the area of this rectangle here. And you will get the correct answer either way. So what we have to be able to do is to take these more complicated shapes and break them down into pieces that we have formulas for. And if we get good at that, it's really going to help us moving forward. So if we want the, we'll say the area of this shape to begin with, because that's what we were already talking about, we'll start off by doing the subtraction method. So if we want to get the area of this shape, it's going to be the area of this bigger rectangle, the one that I've drawn in dashed here, minus the area of this smaller one. So the area of the big, and we can tell ourselves the story of this as we're going, the area of the big minus the area of the small. So the area of the big is going to be the area of our large rectangle here, is going to be 6 by 8, is going to be length by width, so 8 by 6. And we use brackets for our multiply. Minus the area of our small little piece that we have removed here from the bigger piece, from the bigger sheet of paper. So that's going to be length by width is going to be 2 by 1. So 6/8 is 48 minus 2 by 1 is 2. So it's going to be 46 centimeters. And we've multiplied centimeters by centimeters, so it's going to be centimeters squared for our area. And that is how we would get our area. And then if we wanted to get the perimeter of this shape, we've already done a lot of the work for it here, so we need to know the length of all of our sides. But there's something that we might be able to spot in just a minute. We're going to do it the long way first. So let's add up all of the lengths of our different sides. So we have this length plus 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 this length. So we're going to have 6 plus 6 plus 1 plus 2 plus 5 plus 8. That all adds up to 28, and we're measuring in centimeters this time. But if we think carefully about this, did we have to find out our missing lengths here? Because I know in a rectangle that this length plus this length must add up to what? It must add up to 6 centimeters. And this length plus this length must add up to 8 centimeters. So this length plus this length, I didn't need to work out that this was 6 centimeters in this case, because I could have just had the perimeter as 6 plus 8 plus 6 plus 8 is our 28 centimeters. And that is what we've got for our perimeter of our shape. So again, we've broken this up into easy pieces. Now, a little bit more of a reasoning type question. If we are given the one of the side lengths of a shape and we are given its perimeter, how would we figure out what is the length of the missing side? Well, let's fill in the information we know. I know 5 meters is this length. So 5 meters is going to be this length. And whatever this length is, the bottom down here is going to have the same length. So I know that the perimeter would be equal to 5 plus my length plus 5 plus my length is equal to 32. Now this is effectively algebra, but I'm just telling myself the story of what I already did when I was getting the perimeter before. I just walked around my shape. 5 plus whatever this is, plus 5 plus whatever this is. So I have, in total, traveled 10 meters plus twice whatever this length is. So twice whatever the length I'm missing is. If I want to find out what the length is, I could remove my 2 5s away to find out what my 2 lengths must be. So 2 of my lengths would just be equal to 22. Again, what have I done? I want to find out what the lengths are. I know that part of my perimeter is these 10 meters, this 5 plus 5. So I've removed those 10 meters I know about. And then the remaining perimeter is just double this length because I've got the 2 lengths added together. So it's going to be half of my 22. Half of what's left is going to give me my missing length. So that must be 11 meters. And we can tell ourselves the story of how to do this. I'm writing it out as you are going to in the long run. I'm writing this out as you are going to in the long run when we've done more algebra, but you can write this out more English-wise at the moment if you feel more comfortable with that. So we're figuring out what part of the perimeter is our 2 lengths added together, and then half of that is going to be our missing length. And that's how we can tell ourselves the story of how to approach our questions. So we can see here that while we know about perimeter and area very well, we are going to be able to use them more creatively now to be starting to think algebraically, to be starting to break down bigger problems into smaller ones. And that's what we need for now.